All right, it's time for 4.2 polynomial theorems related to zeros. I can't wait. Riverdog Jenny over here cannot wait, right, Jenny? I know, it's exciting stuff. Okay, so we're going to hop to it here. We got to find the zeros by factoring. Okay, this is just a little warm up here, and then we're going to pop into some exciting things that you've seen before a little bit. We're going to go a little further. All righty. Let me get a suitable color here. I'm going to go with purple on this one. So if I want to factor this, I'm going to look for a GCF first. So I'm going to take out an x. I'm going to factor out an x from this, and I'm going to be left with x squared minus x minus 6 equals 0. And now I can factor that trinomial inside of the parentheses. So I'll have x minus 3 that multiplies to negative 6 and adds to negative 1. I've got it. This is fantastic. So I'm going to get x equals 0. X equals 3 if I set x minus 3 equal to 0 and solve. And then x equals negative 2. So those are my zeros. All right. Wonderful. Let's try part B here. What you may notice, you might remember this with doing some either U substitution, or since this is nothing too crazy, what we do is we'll just treat it like it's almost like it's a quadratic, except now what we'll have is x squared, and x squared is my first terms in each binomial. And now what multiplies to negative 12 and adds to negative 1? Well, that's going to be negative 4, and it's going to be positive 3. So we use the same logic that we would with a normal quadratic when factoring, except we're dealing with a quartic function here. So we have x squared and x squared as our first terms, okay? So now what I can do is I can set x squared minus 4 equal to 0, or I can continue factoring it further if I'd like. I'm not going to do that. I'm going to use square roots to solve. I find that to be a little bit more efficient. That's the one thing that's great about math is sometimes I can just choose how I want to solve it if there's multiple options. So I'm going to add 4. I'm going to have x squared equals 4, and then I'm going to square root, and I know I'll get x equals plus or minus 4. Now with this one, I'm going to end up with a negative on the right-hand side, and who remembers how to deal with negatives when square rooting? I do. Jenny, do you remember how to deal with negatives when square rooting? No, okay, she does not. So she's going to learn today. So I'm going to have x equals plus or minus, and I got to take an I out. All right, root 3. Cool. Awesome. Fantastic. So that negative comes out as the I. All right. Because the square root of negative 1 is equal to I. We could really break it down, but we're going to leave it at that. Lovely. Fantastic. Wonderful. One more for the warm-up here. One more for the warm-up. You know, we don't want to pull a math muscle, so we gotta warm up. We'll switch colors because, you know, why not? So it says find A if 2i is a 0 of f of x, which equals x squared plus, x to the fourth plus x squared plus a. So what does that mean? Well, it says 2i is a 0. That means if I were to substitute 2i in, the output would be 0. Okay, well, I could use that. This means that 0 is going to equal, and I'm going to substitute 2i in for x in both of these spots. And now I can solve for a. Now I got to remember my properties with I. So I to the fourth is just 1. So, and then 2 to the fourth is 16. So this becomes 16. And then 2 squared is 4, but I squared is negative 1, so this becomes negative 4 plus a. And that equals, let's see here, 12 plus a. So a is going to be negative 12. I love it. All right. A little side note here. Remember, I is equal to the square root of negative 1. I squared is equal to negative 1. I to the third is equal to negative square root. We'll say negative I squared. So there we go. And then I to the fourth is equal to positive 1. Okay? You could think of this as negative I there as well. All right, the main ones to use are I squared, I to the fourth. All righty, let's continue. All right, so the remainder theorem, it says let f be a polynomial function if f of x is divided by x minus c, meaning like x minus 3, x minus 2, something like that, then the remainder is f of c. So what does that mean? That means that if I were to substitute c in, plug it in, the output is that remainder. Okay, so direct substitution or dividing by x minus c is going to give you that remainder. All right, so find the remainder if your polynomial function f of x is x cubed plus 3x squared plus 2x minus 1, and it's divided by x plus 2. So we could either do direct substitution with negative 2, or we could do synthetic division. So let's review synthetic division. I love me some synthetic division. It keeps my numbers a little bit smaller usually, so it's a little easier to work with without a calculator, which is a nice thing to know how to do. So I'm going to put all my coefficients, so the 1, the 3, 2, and negative 1. If it's missing a term, make sure you pop a 0 in there in its place as a placeholder. All right, I'm going to drop a 1. And then negative 2 times 1 is negative 2. Add down, I get 1. So this is negative 2. Add down, I get 0. And then, so if I have multiplied by, that'd be 0 again, right? And then add, I get negative 1. So my remainder is negative 1. I like it. Awesome. Fantastic. So what I'm going to do now is I'm going to pause the video. I'm going to work this problem out. You can hit play when you're ready to see the solution. So there we go. Work through a synthetic division. Our remainder is 5. If you didn't get that, pause the video now. Take a look at this work. See where you made your mistake. All right? Fantastic. Next up, we have our factor theorem. So it says let f be a polynomial function, once again. Then x minus c is a factor of f of x if and only if f of c equals 0. Meaning if we do synthetic division or long division, we divide out x minus c and our remainder is 0. Or if we directly substitute c and we get 0 as our output, okay? Either one of those, any one of those would work. What we're saying is that f of c would have to equal 0. Okay, wonderful. So the factor theorem consists of 2 separate statements. That's why it's listed as an if and only if. Okay, if f of c is equal to 0, then x minus c is a factor of f of x. And if x minus c is a factor of f of x, then f of c equals 0. This is the new dance move, but it's for the factor theorem and if and only if statements. The if and only if dance move. Okay, I'm gonna move on. Let's use the factor theorem to determine whether the function has the factor. Okay, so we have this wonderful looking function here. It's a cubic. I like cubic functions. A negative cubic. I could use that to talk about the end behavior if I wanted. Alrighty, let's set up some synthetic division here. So I feel like that's going to be the easiest way to keep numbers a little more manageable. So I'll have negative 2, and then negative 1. Keeping an eye out in case we're skipping any terms. I do need to throw a 0 in the place, but this one we do not skip any terms. Okay? And then we're going to go through a synthetic division here. So I'll drop the negative 2. Multiply and I get 2. Add vertically I get 1. And then I'd have negative 1 when I multiply negative 1 and 1. And then add vertically I get 3. Multiply negative 1 to 3 and I get negative 3. Add 0. My remainder is 0. So what does this mean? That's important. Okay? That means that f of x has the factor x plus 1. And we can do more than just this with what we have going on here. We will build on that. Okay, so we can factor these things. We can divide out these factors and then start analyzing the function even more. But we'll leave it at this for now. So why don't you try the next one on your own? I'm gonna pause the video, and then you can check the solution. Alrighty, so I see that I have a remainder of 4 in this one. That means that f of x does not have the factor x minus 1. And we could say even more specifically, since, or just I guess maybe in another way, f of 1 does not equal 0, we know that it's not a factor of f of x, okay? Since our remainder is not 0, not a factor. Cool? Fantastic. Wonderful. So I could have done this again with just substituting 1 in for x, and I would get 4 when I substitute 1 in for x. Keep that in mind. But synthetic division is oftentimes a little bit easier to work with size of numbers. So I've been talking all about this whole, we can do it by division, we can do it by substitution. Let's actually do this. We're going to try these here. I'm going to work out the first one, pausing it since we've done division several times. We'll go over that one, and then we'll talk about the substitution way, okay? That means pause the video and try the problem on your own. All right, so for this first one, we have a remainder of 0. This means that f of 2 equals 0. And since f of 2 equals 0, then x minus 2 is a factor of f of x, okay? Since f of 2 equals 0, x minus 2 is a factor. Now let's show that using substitution. So if I did that using substitution, I would, I'm going to give myself a little more room, and we'll do a different color here because that's fun. I'm going to go light blue. So I'd have f of 2, right? I'm going to substitute in 2 because I'm trying to see if x minus 2 is a factor. And throw it in parentheses. Oh, this is so fun. I love doing this. This is my favorite. Let's see if I run out of room here. Oh my goodness, I might run out. Okay, now if I evaluate all that stuff in my head, oh my goodness, there's so much going on here. Or if I throw it onto a calculator. But if this is no calc, that just looks like a pain in the butt. But it will equal 0 if we do that, okay? Which, once again, since f of 2 equals 0, we're back to this statement down here. Since f of 2 equals 0, then x minus 2 is a factor of f of x. How exciting is that, Jenny? She fell asleep in class. Now, don't pull a Jenny here and fall asleep in class as well. We don't want to do that, all right? Because then you might miss some exciting stuff like we have right now. All right, let's try another one. All right, this might seem a little redundant here because we're like, oh my gosh, another one of these? Well, let's see here. We want to find the remainder if we're doing x to the 5th minus 2x cubed plus x squared minus 4 divided by x plus 2. So we're going to find the remainder, but we got to divide it out. Well, how about synthetic division? That's one method that we know. So I'm going to throw negative 2 in the box. And now I've got to have 1 for my first coefficient, but we don't have a degree of 4, right? We don't have an x to the 4th term. So I have to put 0 in for that one. And then negative 2, and then 1 for my x squared. Ooh, I'm missing my linear term. So I have to put in a 0 for that, and then a negative 4. All right. Now I can do some synthetic division. So I'll let you guys do that, pause the video, and then check it. Alrighty, so for this one here, we see we have a remainder of negative 16. Well, since f of negative 2 does not equal 0, then it is not a factor. Well, actually, no, we're not even asked to do that. Pump the brakes back. I'm just in that mode right now. All we were asked for was the remainder. I've got it. It's negative 16. Excellent. The other way to find a remainder would be with direct substitution. So if I were to plug in negative 2 for all my x's and evaluate, you got to be careful when you're doing this in your head because you're going to have a negative for this first term, right? Because it's to an odd degree, and same with this one, but then it's multiplied by negative. So be very careful. It can get messy, but you're going to get negative 16 once again. So we know that f of negative 2 equals negative 16. Whether we do it with synthetic division and find a remainder, long division and find a remainder, or with direct substitution. All of them would work. All right. I like it. Fantastic. I almost did too much. I almost did not what the question asked. That would have been terrible. Got to read directions, right? Got to read directions. Okay. This is our last example here. Yes, I believe it is the last one, and it's a lovely one. Okay. It says if x equals negative 1 and x equals 2 are zeros of the polynomial. So it's saying that those two are zeros. And y equals, or f of x equals, x to the 4th minus 2x cubed plus x squared minus 4 are, what are the remaining roots? You may have seen this in Algebra 2 Honors before. So how am I going to find my remaining roots? Well, what if I were to divide out the factors, right? The factor x plus 1 and x minus 2. I knew that from my zeros that are given. If I divide those out, and then I'm left with a quadratic because I divided out twice from a quartic function, then perhaps I could manage that quadratic that's left over after dividing those out, right? Now, it's not like we turn this into a quadratic, but we're taking out some factors. So let's get to work before we talk too much. So I'm going to throw a -1 in the box, and then I'm going to work the synthetic division. When you set this up, we have then 1, and then 0 and -4. Okay, so I had to put in a placeholder there, right? Alrighty. So I'm going to drop my 1. And then I'll have -1, -3, +3 when I multiply, that's 4, -4, add +4 when I multiply, and boom, I have a remainder of 0. That's excellent. All right, now I'm going to do synthetic division again, because what I have here is a cubic polynomial if I were to write it all out. Okay, then let's see here. I'm going to have 2 in the box, and I'm going to throw 1, -3, 4, -4. And I'm going to do synthetic division again. So I'm going to have 1 drop down, multiply, I get 2. That's -1 there. -2, 2. Multiply those together, I get 4. And boom, a remainder of 0. Okay, awesome. We're getting some places. You got 2 remainders of 0. That makes sense because we said they were zeros, right? So they should divide out with a remainder of 0. Whew. Man, I'm tired. Need a break here. All right, no breaks. Okay, so what I have here is I have x squared term, right? My quadratic term, my linear term, and my constant. So what I have here is x squared minus x plus 2. That's what remains, okay? Because I divided out, I'll put these in a different color since they've been divided out here. I divided out my x minus 2 and my x plus 1. Those have been divided out, not removed, but just divided out. So now I can just work with this guy right here. Now I don't have anything that multiplies to 2 and adds to -1, so I do need to use quadratic formula here. So I'm going to set this equal to 0 and use the quadratic formula, which would be -b, so -1, which would be 1 plus or minus the square root of b squared, -1 squared, minus 4 times a times c all over 2a. Man, love this formula. It's just fantastic when I'm in a bind, you know what I'm saying? Alrighty, so we have 1 plus or minus, and then I end up with, it looks like a -7 inside my radical, right? It's going to be 1 minus 8. Oh, man. Negatives inside of a radical? Can we handle that? Jenny, can you handle that? I don't know. Maybe she, there she is. Nope. She can't handle that, but we can. All right. So that's going to be 1 plus or minus I root 7 over 2. Boom. There's my 2 remaining roots. X equals, we can even toss in there because, let's be formal. But those are my 2 remaining roots. That was a doozy. I divided out 2 factors, 2 zeros that I already knew, and I analyzed that quadratic that was left over, right? But again, not like they were gone. This is my whole polynomial, but in a factored form, right? And then I was able to use that last part there. Awesome. That was fantastic. That was fun. I loved it. Jenny loved it, even though she was sleeping the whole time. You guys have a great day. America, freedom, rock and roll, Costco. Live the Raider way all day, every day.